The second type of simple machine we're going to look at are pulleys. And these are probably the least complicated, even though they look the most complicated. All a pulley is, it's a wheel with a groove that a rope fits around. So you've seen pulleys before in labs, but now we're going to look at pulley systems where you have several pulleys with the string wrapped around them. And this one's pretty easy. Your ideal mechanical advantage, or the IMA, is just the number of ropes that support the object. So if we look at these pictures here, and I draw a little dotted line, these are 3 cases, that was not very dotted. So a little dotted line through the center. This one has 1 supporting rope, so that would have an IMA of 1. This one has 2 supporting ropes, so this IMA would be 2. And this one has 1, 2, 3 supporting ropes, so the IMA there would be 3. So IMA for pulleys is just the number of ropes. And then you would be able to find the AMA the same way as we did for inclined planes. It would be your output force over the input force, where the output force is the weight, so that would be your hanging mass. And the input force would be how much you're pulling on the string with. So those would be your input forces. So we'll do one quick example with this. We want to determine the IMA, AMA, and efficiency for this pulley system. So remember, IMA is just the number of ropes. So if we count that are supporting the object, so again, I usually draw a line, dotted line going halfway through, and count the ropes. We have 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. You would have an IMA equal to 6. Your actual mechanical advantage is equal to the output force over the input force. So that would equal your output force, which is the weight, 100 newtons, over the input force, that's how much is being pulled, 22 newtons. 100 divided by 22 equals 4.54. So AMA of 4.54, IMA of 6, percent efficiency is equal to AMA over IMA, and that's going to equal 4.54 divided by 6 times 100%, and we get a percent efficiency of 75.8%. And that's it for pulleys. We'll do a bunch of practice with this. We'll also do a lab with pulleys so you can see how they work. They're not necessarily the most efficient because what happens is inside the pulleys there are frictional forces. So you've seen pulleys be used before, especially to lift things. The classic example I can think is like a bucket out of a well. That would be kind of a pulley system, or ropes with stages and curtains and all of that. But easiest thing to remember, number of supporting strings equals IMA, and AMA would be your output force over your input force. What you'll also be able to look at if the pulley does move the object, so really what's happening is this is getting lifted up or lowered down. It would be your, and this could also move up or down because the rope is all connected. So if you have the distance that this moves and the distance that this moves, you could also find the IMA using that. But we'll focus mostly on number of ropes and input-output forces.